Hello. My name is Emery. Welcome to Coding Australia. This project is called Number Plane. segue from M block to canvas.
Or say you were learning the shapes and where to put them and position them, different types of shapes and so forth, and you would have come across translate, which would have meant changing a heap of numbers and putting the origin, which normally sits up in the top corner, down into the middle of the screen. And this set of videos is going to create a number plane, and then we're going to have a little play with it for a while. Okay, so first things first, I'd like to acknowledge Dive In, which is one of the links here where I got the idea from. They actually walk you through step by step how to draw the grid, and I'm doing something very similar here, although I've changed it a little bit. Okay, so what we're going to do is we are going to draw the grid. The grid will look like that when it's done. So let's just go back through and have a look at what's going down here. First things first, we declare our area, which is 600 by 600, and the background's white with a black border, and the standard opening scripts variable declarations to get our canvas 2D canvas declared, and one more statement here that's going to translate the origin to the middle. Alright, and then we'll call up a function called xy_grid, and then that xy_grid will draw the grid and the axes. So let's take the axes out for a minute so we can just focus on this part. Alright, so that part is here. It's two loops, the vertical lines and the horizontal lines. And here we start at minus 275 because we've translated to the middle. So think about it. We want to start at no point starting at minus 300, that's the border. And we're going to keep going until we get to 300, and we're going to jump by 25. We're going to move to where X is and start at minus 300 at Y and 300. So it'll start down like this. It'll work its way across doing those ones going down like that. And the other loop is very similar, cut and paste, and just change your X's to Y's and make sure you swap your constants across to the X value, not the Y value, and then we're going to have a grey looking colour, and then we draw it. So that's how you get your grids. This second part gets you the horizontal lines going that way. So that's the first part. Now the second part, what we want is we want to do a few things. First things we want to do is we're going to draw the x-axis, draw the y-axis, and then put numbers on the axis. And we'll use black to do it. Okay, so x-axis, we start at minus 300, we draw a line to 300. Okay, so that is, hang on, it would help if I took out the comment. Let's try that again. Alright, so that's this line here, and you'll notice a little bit extra here. Those are the little arrowheads. So once you've got all that code going, it's similar to the drawing of the grid. If you cut and paste that to Y and then make a few swaps here, have a look, swap it over, so you're not coding every line here. Or you could if you want, I guess. A lot of it's cut and paste. Then you get to there. Alright, so let's just take this out for a minute. I'll put it back in a sec, and I'll just show you what you will get. Okay, you'll get that, like so, the little arrowheads on the ends. So that's what the x-axis and y-axis functions are doing. And then finally, for the moment, oops, where am I? We're putting in the numbers. There's not much to it. A very similar setup. I probably could have done this at the same time, but we won't bother. It's better to split it up so you can see what's going on. But very similar. You're moving in a very similar loop. The loop does. We've made the font smaller, and we've used a thing called text align center. Now, have a look at this. If you play with that and go away, David talks about this stuff, and you can go to the Web3 Schools place. I'll tell you about this placing of text in the right spot. So because you're using the same loop and you're moving and drawing a very small line that's just a little line on the grid, on the axis itself, and then you use that context fill text to string, that will take the value and turn it into a string and display it in that position. That's what that thing does, which is rather neat. You come across that in other places as well. Then when we go to Y, we have to say we want the text based line, because we're going up and down this time. We want that in the middle. If you play with that, top and bottom, this one left, right, center, you'll see what happens with those values if you change them. And so then you draw that, and then finally we're just going to tell it it's the X and Y axis. And excuse me, almost black. Almost black is taking a slug of coffee. That's better. Alright, and then yes, I am human. And so that there gets you what you want for the numbers and the axis. So let's see what we've got here. We'll save that. I think I've oh wait a minute, did I comment? No, I think everything's there. Let's check. Yes, it is. Alright, so those text align statements are to put these right where you want them. And there's just little negative signs there too, by the way. Comes through there like that and puts it out through the bottom. And so that's how you draw your basic number grid or number plane. So we got all this set up, and from that we've created a number plane which looks like this, which is good. But if you were going to use the number plane in a way that you would do for coordinate geometry in your maths class, then there's a couple of things you'd want to do. First thing you'd want to do is you'd want the negative y to be down here and the y positive to be up there. And the second thing you probably want to do is you probably want to scale it a bit. So instead of it going from 300 to minus 300, we might make it go from minus 12 to 12. So 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Yep. So each grid will be one unit. So for us to do that, we just have to make a couple of changes to our code. And all these numbers are going to change as well. So let's just see what we're going to do. This is what a scaled number plane looks like. Grid's the same. This is the same, that's the same. This is where things change. We include a canvas called context scale. We're going to make it 25. Scale it up 25 times. So if you think about it, I think 12 25s is 300, so that's why I was saying 12. Now the other things that start to kick in here is your line width goes up as well. So we're going to set a very small line width to retain that grid size. And the other part where we have lots of fun and games is to do with the fonts. And I'm giving you this, I've got this from somewhere, had a look at around to find something that will give us a reasonable size font. But you're going to spot something that gets a little bit of a pain to deal with, and it's something that I'm not going to worry about here because it just gets too fiddly. But you're quite welcome to go away and sort it out. You're going to see what's going to happen and see what I mean. Alright, now there's a lot of guesswork goes on here. This part's pretty specific. We want to retain all those little axes and lines and stuff like that, and we start at 12 and we move, as you can see, our arrows are a little bit different, but the numbers are proportionally the same, if I can use that term. They are proportionally the same. So they'd be sort of roughly 1/25th of the numbers that were in the original one up here. So you look at these, and about 1/25th of those will give you those. Alright, so the structure doesn't change, just the numbers do. And down here we do a little bit of a fiddle here, and if you do that, the positive becomes negative and the negative becomes positive. So it's not strictly speaking the right way to do it, but it works. And if you sort of, you will, if you go and look at scale and stuff, discover that you can make these negative and then it flips it over. The sad part about that is it also flips everything over, so it starts, you've got to kind of decide where you want to go. So I've done it this way, other people do it different ways. You're playing with this here, making this slightly bigger. I might have put these in a slightly different spot, these X values, but everything else is pretty much the same except for that little bit there where you change the negative to positive and positive to negative. And if you cut and paste and do your editing and get it all correct and add these extra few bits and pieces, then what you get is this. Alright, and the bit I was mentioning is that's really, really fiddly, and we're going to look at another video here. We're going to start graphing some linear and polynomials, y equals x squared, etc. stuff, to show you how to graph those. You'll discover that things like this start to happen. You get this kind of space around the letters. Now, there's ways to solve that, but I went and had a look into it. It's more trouble than it's worth at this moment in time to figure out how to fix these things up when you resize your fonts and scale and do stuff. For some reason the negative just puts itself right in there against the letters. There is a way around it, but I'm not going to bother with it at this stage. It's a bit fiddly. I could give you a quick suggestion. For this lot, you could just have all positive numbers and then just stick a little minus sign in a different spot right down there. Maybe ditto for these as well, so just have all positives, no sign, and then place a little negative sign in a different spot in a little loop, but I'll let you worry about that. Alright, so this is where we finished off with the number plane scaled and this little negative situation. What we're going to do now is we're going to put in some what I call linear equations. If you don't know about this stuff, then I wouldn't even bother watching these videos, but if you do, you should get this. So we're going to put in a few lines and label them. Alright, so the way we do that is, first of all, let's just go back over here for a minute and have a look. Here's the new one, which at the top part is exactly the same. So we're adding to what we've already got. I moved that font size thing down too, by the way, so it was up the top. I sort of put it small about where it actually is needed, which is here and then down here. So the same thing happens here. So it's been moved, nothing changes. The number axes are here, and then the font part is here, and then the bit that's new are the lines. So we've got a new one called draw lines, and we're going to do something here that's a little bit different. We're going to name our lines first, and then we're going to put in another context scale, and this is the one that is going to flick the y-axis over. Remember I said earlier that it hadn't actually flicked it over, just the way you've labelled it, it's putting negative down here. Well, now once you do this, that's what's happened. But if you do that first, things sort of go a bit funny here with things getting upside down. So we do the names first. These are what they are. We've got lots of little fiddly things happening here. It looks really fiddly, but it's just to get things in exactly the right spot, and there's a reason for that, and it's got to do with that resizing. So when you scale things up, your negative sign winds up sticking right beside the 4. So I've split things up here, and we've got 3 lines we're going to draw: y equals x, y equals 2x, and y equals 4 minus x. Those are the three labels that are there. If you get all that right, they're going to appear up the top. Now, then my fairly ordinary way of labelling the actual equations themselves: y equals x, y equals 2x, y equals negative x is actually been changed. I started out as that. It's actually now y equals 4, and I'll rename it minus x, like that, which is horrible, but that's the way I'm doing it. Y equals 4 minus x. So down here, y equals 4, you've probably got a better way of doing this, minus x. Okay, and these are the way they're drawn. Now, because the scale's been changed to that, they are literally drawn in the correct position. They wouldn't normally be. They'd be going in the opposite direction because of the position of negative when you use canvas, but that's been fixed up so that they just go exactly where they're supposed to go. So move, it's just a line. So you start at a particular spot, and then you just go through the process of y equals x, and then you draw it. And this one's red, this one here's 2x, so you start in a slightly different spot. You can start further out, but you just won't get anything. And this is 2x, same thing again. This one's blue, and then the next one, start back where you were before at the minus 12, 12 position. Okay, so that's up here now. This one, by the way, is down there. So we've swapped things around, and that one's going to be green. Now let's just see what we got for our troubles. So there it is. That's your y equals x with the label, y equals 2x, and y equals 4 minus x. And you can have all sorts of fun and games playing with those and writing new ones and seeing what sort of results you get. Right, moving right along, this is where we left off, and this is what we got. And now what we'll do is we'll do a couple of polynomials. So we'll do y equals x squared, y equals x cubed, and x equals y cubed, which if we get everything right should sit just there. Now the process isn't much different. There's a little bit of fiddling. To get the lines, and what we're going to do this time is be a bit clever with our labelling, and we're actually going to put the labels as close to the actual lines themselves so they sort of follow in the same direction. You can go back and play with this one to do that too if you wish. Alright, so let's go and look at what's happening over here. Everything up the top, exactly the same. Nothing changes till you get down to the bit that says draw lines. Now, this has changed. Curve names. And then we do the scales, flip over, and then we do the actual 3 lines. This is where the fiddle happens, and it's fiddly. It's not hard, it's just fiddly. And what we're doing is, so that we can put the lines to follow the labelling to follow the lines, we do this. Rotate a little bit, colour, and we're doing x equals y cubed first, and you'll see y when I show you the graph. This is y equals x squared, so there's a lot of fiddling here. Change of the size of the actual fonts, position, size of the font, so we get y equals x in the squared, and the 2's a bit smaller in a slightly different spot, and the y equals x. And these are mucking about here. You can play all you want with these position numbers all the way through here. All those position numbers. Okay, so that's the first bit. Second bit, the other thing is here is that when we were doing the original, the previous difference here was just x plus, so up by 1 unit. But if you do that, you get your curve loses its curve. It's sort of just straight lines between each whole number. So if we make the increments a quarter instead, the line gets a lot smoother. So have a look at those. Let's make sure you note those. This one's back to front, sort of, as it were. X equals y, y, y. This is y equals x, x, y equals x cubed, x equals y cubed. But apart from the increment, there's not much else really there that's different. It gets you a different result. So all this stuff here is just changing what you had before and doing a bit of fiddling with the increment. And then when you do that, and it all works out, you get this. And so a very smooth curve, and an attempt to put this, I could probably move that a bit closer, and what happens is it spins around, and if you keep rotating, it winds upside down the bottom here and comes back where it came from. So I'm getting it as close as I can, but it could be closer. One of the things to notice here is this one rotates a little bit, these two rotate a bit more, and then you've got to go back to where you came from. You might like to take that out and see what sort of an effect it has down here. You've got to get back to 24. Alright, it's 2 math pi is a circle, so that's why the divide by 12 minus 1 minus 4 minus 19, so it rotates in that direction. But you can have a play with that, see what happens, the sort of effects it has on that.
Thank you, too.